before the vacation?
Sound.
Sound. Oh, okay. Sound you are saying. Okay. I thought like some you are saying. Sound chapter was going on. Okay. 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 By the way, Prinka, can you quickly provide me the list of the chapters that has been completed in your school so far?
Sir, in class or in message?
In your school. In message you can send it. Okay.
Okay, sir. One
Uh-huh.
minute.
Okay, just type the chapter list. Let's continue with this chapter, that is friction, which we have started. Okay. So as you guys know that when we do different kind of tasks, like suppose when we are trying to move a given object, right now, so we will feel some resistance in moving that object. Like as this boy will be moving this sofa, so will he be very easily able to move this sofa? Is it push, just with a slight push, it will go several meters away? He will obviously feel some resistance. He will have to put some effort while he will be pushing it, right? So what is the cause behind this resisting force? Huh? Why he has to put so much of effort into pushing this sofa set, the sofa? Or why is it that when we are cycling, after we stop pedaling, the cycle eventually comes to a stop? Getting it? Or why is it that after certain period of sorry, after certain period of time, the parts of the machines uh, gets weird and teared, right? It starts to break down. Hmm? Yeah, Mustafa, how are you? Try joining the class on time. You are late today, almost 8 minutes late.
Fine, sir. Sorry, I completely forgot we had class today.
Oh no, we have class on Tuesday, Thursday, and Saturday. No worries. Yeah, so I was giving a general introduction about the friction. So where I told you that whenever we try to push something, right, pull something, right, so we feel some resistance. There is some hidden opposing force. So that hidden opposing force, which we are talking about, is basically friction. Okay. While friction at some place is advantageous to us, it is useful, but at various places it proves to be disadvantageous. All of you, turn your cameras on. Mustafa, turn your camera on. Getting it? So it makes our life easier also, but at the same time, it makes our life hard also. Getting it? No? So in the chapter, we will learn in detail about what is friction, how friction is caused, what is the cause behind the friction. Then what are the effects of friction? Because of friction, what are the effects? Like in winters, if we were to rub our hand, so due to friction, heat is generated. When we rub our palm like this, heat is generated. Okay. So there are various effects of friction we will learn about. Like for example, heat will be generated because of friction. Hmm. Then we will learn what are the applications of friction in our day-to-day life. Right now, what could be the application of the concept of friction? Why is it that when the tires are made, suppose if you were to design a tire, so will the surface of the tire should be very smooth, or should it have some irregular, should it have some grooved patterns on it? Huh? How would you design a tire? Should it be completely round and smooth, huh? No patterns in it, or should it have some patterns, some grooved patterns in it?
So it should have patterns.
Patterns, no? That is the thing. Getting it? So such things we will learn, like what are the application of friction in our day-to-day life. Okay, how where while we are manufacturing a machine, so the concept of friction is taken into consideration. Okay, like how friction can be minimized, or in areas where we need to increase the friction, so how we can increase the friction, what are the factors that has to be taken into consideration. We will learn about this. Then further, suppose if there's an object placed in front of you and there are two boys and both of them are pushing that object from the opposite side, one pushing it from this side, one pushing it from the other side. So what will be the overall force, or like I mean to say, what will be the overall friction acting on the object, like what will be the overall force? Slightly we have learned about such concepts in the chapter force and pressure as well. So we will do some numerical problems wherever possible. We will do some numerical problems from friction. Then we will learn about different types of friction. Like we have sliding friction, we have a static friction, we have rolling friction. Why is it that the wheels of the vehicles are made circular and not rectangular or triangular or rhombus or trapezium or or of some other shape? So we will learn about such things. So that is what we are going to be discussing in this chapter. Also, we will learn about the case of friction in the fluids, like friction in gaseous medium as well as in the liquid medium. Okay, na? So it's not like friction acts only between two solid objects. Friction acts in the gaseous medium, in the liquid medium as well. And how we can minimize the friction? Why is it that the front portion of the aeroplane has less surface, like it's pointy, it has a streamlined surface. Right now, it has a streamlined body, I mean to say, just like a fish or a bird has a streamlined body. So, in order to reduce the drag, in order to reduce the air resistance, they have such a body. We'll be learning about that. Getting assume if the aeroplanes were to be made of a square shape, right? Square shape or rectangular shape, how difficult it will be to fly them, isn't it? Okay, these are the chapters that has been done in the school so far, Priyanka, right? Okay, 1 minute. You guys give me 1 minute. Chapters completed in a school. They are crop production and management in microorganisms, combustion and flame, force and pressure have been done, and friction also has been done. Okay. Okay. Like here you can see, as we are trying to push this object here, we are trying to push it in the falling direction, but we feel some resistance. We feel some opposing force. We feel as if someone is pushing it from the other side also. So that is basically because of the force of friction. Okay. Then there are various examples of the frictional force. Uh, Most of the tasks that we do in our everyday life, in fact, every task that we do in our every life, there's a concept of friction involved there, right? Whether it be simple act of writing something on a piece of paper, right? Whether it be applying the brakes of in the car, right? Whether it be holding something, like I'm holding something in my hand, suppose like this. Hmm. You know why we have got those patterns in our palm? That is basically fingerprint. All of us have a unique fingerprint. If you were to look close into your fingers, into your palm, you will see that those linings, right? Those linings that forms a pattern, and each one of us have a unique fingerprint. Is there some role of that? Think about it and tell me.
So it provides friction to hold objects.
Yeah. Give me 1 minute. I need to just throw it this water and 1 minute. Yeah. What were you saying?
Sir, it provides friction to hold objects.
Exactly. Right now, it actually helps us in grabbing the objects. Right now, it increases the like it increases the friction so that we can hold the things very easily. Right. And now, on the other hand, suppose if your hand were to be oily, you dip your hand in oil and then you try to hold a cup of water or something, then it will become a difficult. It will be slippery. Getting it? Okay. So in our day-to-day life, there's a No matter what kind of task we are doing, there's there's involvement of friction almost everywhere, right? Almost everywhere. Okay, can you guys give some particular examples of frictional force other than this writing and the car brake? I
Sir,
think of
walking,
uh, walking. Okay,
swimming,
what? Walking and
swimming, swimming.
swimming. Yeah, good. Swimming.
So atmosphere,
Atmosphere.
like
Um,
and objects will be there.
you can say flying. Flying, there will be air friction, air resistance, right?
Yes, sir.
Particularly flying aeroplane, right? And
Sir, lifting of weights.
repeat again.
Sir, lifting of weights.
Lifting of weights, yeah. Lifting weights. Okay. And
Sir, turning pages of a book.
turning pages of book. Okay. That can also be taken as an example. Good. And
Pushing,
pushing. Okay. But particularly give some examples from day-to-day life, like particular
Sir,
okay,
examples.
so moving the mouse on the mouse pad.
Okay. Moving the mouse on the mouse pad. Okay. Okay. There we ensure that the pad is smooth. Right now. It's smooth. Okay. Okay. And tires of the vehicle, you see the tires of the vehicle,
Yes, sir.
right? That also needs to have some like pattern on it, right now. So tires of vehicle.
Sir, playing the guitar.
Playing the guitar. Hmm. We can take that as also an example. Okay, playing musical instruments, right? So there are a lot of examples of frictional force in our day-to-day life. Okay. Further, the question comes like, how do we define the friction? Okay, na? How do we define the friction? So 1 minute. By the way, is friction good or bad? You guys tell me so far from the discussion, this much you should be able to conclude, by the way, I think. What would you say? Like friction, is it good or is it bad?
So friction is also good and it's also bad.
Hmm. So we can say that friction is a necessary evil, right? It's a
Yeah.
necessary force. Okay, no? But why we're calling this as evil?
Sir, because sometimes friction can wear out the machine parts and shoe soles.
Hmm. Like when you have purchased a new shoe, right? So walking wearing a new shoe is very comfortable, right? No, you'll be having a good grip over the land, over the ground on which you are walking. But as it becomes old, like 1 year, 2 year, 3 year, or after 4 5 years, so the sole of the shoe it wears out. It becomes smooth because of the regular friction, right? So there it's kind of becoming a evil, even in the sense basically like this. That's the disadvantage of the friction. But the advantage is that because of the friction you were able to walk easily, and because of the same friction the sole of the shoe has basically it has become flat now because of the friction. So that's why we are saying that the friction is a necessary evil. We say that friction is a necessary evil. Getting it, everyone? Okay, na? So friction, it's the force that resists the motion between two surfaces that are in contact with each other. Like there are two surfaces, like there are two books in my hand. I'm trying to move one book over the another book. I feel some resistance.
I can't hear you.
Sir, I can't hear you.
I can't hear you.
Hello. Am I audible now?
Yes,
Yes,
sir.
sir.
Yes, sir.
Oh, for how long I was inaudible?
Sir, for like
Sir, the
3 to 5
minimum.
minutes only.
Oh, don't know why this issue is happening. Maybe there's some issue with the audio jack, I think. Okay, see. So far what I have said that friction is a force that resists the relative motion between two surfaces that are in contact. Like when two surfaces are in contact, I am trying to move one object over the another object right now. So I will feel some resistance. The friction will stop, it will try to stop the movement of one object over another object. Then it impacts our daily activities, whether we are walking, whether we are writing something, whether we are running complex machines, every task which we are doing, right? Whether we ourselves are doing or whether with the help of machines we are doing it, friction is involved there. And it is often called as necessary evil. Necessary, one thing like we have already discussed how it is necessary right now. if the sole of the shoes were to be made flat, right now, so you will never purchase such shoes. No, the company will have to shut down. So on purpose, the sole of the shoes are made rough, right? Some patterns are made over it. But over the course of time, as you regularly use it, so after some time, it wears away, right? It becomes flat and it is of no use then. And that thing has also happened because of the friction only, no? So that's why it is often called as necessary evil. Further, what I was saying that it is always parallel to the ground, or basically parallel to the surface. So this is the surface over here, this black line. You guys keep your cameras on. Abu Bakr, Priyanka, keep your cameras on. What's the point in attending the class if you're not interacting, if you're not asking questions? See, that is the surface and that is the force of friction. So you see how the force of friction, by the arrow you can see like how the force of friction is always parallel to the surface of the object, right? That object could be anything, that surface could be of anything, like it could be the ground, it could be a table, or it could be anything. So force of friction is always parallel to the surface. Getting what I'm trying to say? Like try to understand in the following manner that this is the surface, or like this is the surface, okay, and this is the friction. So friction will always be parallel, it will always be parallel to the ground. Getting it now?
Yes, sir.
Yes,
Okay,
sir.
so that's the thing. It is always parallel to the surface. It is always parallel to the surface. So if a definition about friction is asked, you can either copy the same definition, or if you have understood it completely, your answer writing skill is good, so you can write it in your own words. Okay, you can write it in your own words. Okay, moving further. So friction, as we have already learned, that friction always comes in existence. The same thing basically, like it's essentially a force that comes into play when two surfaces comes in contact with each other. It acts as a resistance opposing the motion that occurs between these surfaces. Further, it's a universal phenomenon. Huh? Universal phenomenon. What do we know about the universal phenomenon? Like, what does the term universal phenomenon means? Huh? Universal, you understand, like something that's applicable, that's everywhere. Huh? So universal phenomenon basically means that that's something that exists everywhere, that can be felt everywhere, right? And that can be observed everywhere. Getting what I'm trying to say, right? So it's a universal phenomena. Okay, na? Like it's not like if I am rubbing my hand, or like if I am trying to move a piece of rock, I will feel some resistance while you are moving that piece of rock. You are thousands of kilometers away from my place, and if you are trying to move it, you won't feel the resistance. It's not like that. So friction is universal phenomena. It's applicable everywhere. Right now, it will be felt and observed everywhere. Right. So whenever surfaces will interact, by interaction here we are talking about contact-based interaction. There has to be a direct contact between the surfaces here. Right. So friction is a universal phenomenon that occurs whenever surfaces interacts, and it's responsible for various effects. Because of the friction, what happens? Right. You are at full speed, you are cycling, right? No, at full speed you are cycling to somewhere, and suddenly a dog is passing by, so you have to instantly apply the brakes. So suddenly your speed, the speed at which you were driving, now suddenly it reduces. So because of friction, right? Now the rubber brakes, it came to the surface of the rim of the cycle, you understand, right? That wheel basically. And then the speed slowed down, the body slowed down. Okay, or suppose a big piece of rock is kept somewhere. Okay, na? It is kept somewhere, and I'm trying to move it, but it is not moving. Right? I'm trying to move it, but it is not moving. So there also there's a huge amount of friction between the rock and the ground over which it has been placed, and because of that huge amount of friction, I am unable to push it. Right? Getting it? So the second paragraph here is very important. The first one is easy, which we have been discussing the same thing for a while. Second paragraph, it's important. Like first, it's being said that friction is a universal phenomenon. What does it mean? That it can be felt everywhere, observed everywhere, whenever two surfaces
Sir,
or more than two surfaces will interact. Yeah.
sir, outside Earth also.
Outside the Earth also. Yeah. Outside the Earth, but particularly how? In what scenario it can be observed? Like suppose I am in the space station, right? So there I can observe the friction, right? Or I am on a planet, or let's suppose I'm on a big asteroid right now. So then they are like, or basically thing is that even outside the Earth, whenever two surfaces will be rubbed with each other, friction will be caused because of that also. Getting it now? So friction is not limited only to Earth. Okay, now the concept of friction is not limited only to Earth. Getting it? So that is the thing. It exists wherever objects interact with each other. Okay, now that is the thing. Although we describe the outer space like it's completely basically vacuum right now, but it's not empty. Is the outer space completely empty? Tell me. Is the space completely empty?
No, sir.
There are planets, there are stars in it, right?
Yes,
There are
sir.
so many asteroids in it. There are moons of the different planets. But the reason why the space feels empty because all these celestial bodies are millions of kilometers away from each other, right? There are so many thousands and thousands, lakhs of light years away from each other. Getting it, everyone? Okay. So that is the thing. Okay, from space, I have this question. Like recently, an Indian astronaut has went to ISS, to International Space Station. You guys know the name of that astronaut? Subhanshu Shukla. Okay, na? Nearly after 41 years, he's the second person to have visited International Space Station. That is Subhanshu Shukla. Getting it, Priyanka and everyone? Okay.
Yes.
And who was the first person to have went into International Space Station? You know, his name starts with R, by the way. It was Rakesh Sharma. Ever heard of the name?
Sir.
No, sir.
No. Okay. Like
No.
these are some general facts like one should know. I think. Huh? You guys participate in quiz or not? You have quiz competitions?
Yes, sir.
You have. Have you participated ever? Like in the past as a kid, have you?
Yes, I have participated and also got selected, but then it's got cancelled.
It got cancelled. Okay.
Yeah.
Okay. 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 No
2
worries.
times.
2 times, and both the times it got cancelled.
Yeah.
Oh. Okay. So the thing is that so friction is applicable even in the universe. Okay, like in the space also. That's the thing. Further, it's responsible for slowing down the moving objects, or it will prevent the stationary object from moving. So key takeaway from this is that it is a universal phenomenon. Second, it slows down moving object, or it prevents. What does stationary mean? Yeah,
Something that's not moving.
that is at rest from moving. That's the thing. Further, you can see here in the given diagram, it's shown that the surfaces of the objects are never completely smooth, right now. Although there are some exceptions, like the surface of the mirror is almost smooth right now. That's why it's the best reflector of the light. Okay. So we are seeing that surfaces of the objects have small irregularities in them, micro irregularities on them, as you can see here. Right now, it's not completely smooth like this, but it has some irregularities. Both the surfaces you can see here. So as the surfaces of two or more than two objects comes in contact with each other, these irregularities gets interlocked into each other like this. It kind of gets interlocked into each other right now. So as you will try to move it, so you see that how the surfaces have got interlocked like this. Getting it, everyone? Right? So suppose that if these irregularities are more, the irregularities are more right now, then you have to put so much of force, you have to apply extra amount of effort into making the object move. But if these irregularities are less, the interlocking effect will be weak, then you will be it will be easier to move the object. Getting it now? So that is the thing over here. Okay, some of the important points to consider about friction is that friction always comes into existence when two surfaces interact with each other. Okay, then frictional force opposes the relative motion between the surfaces in contact. The same thing we have been discussing about. Then force of friction acts opposite to the direction of motion of the object. This is the important thing here. Okay, you are trying to move the object in the left direction, but friction will oppose its movement and it will apply the force in the right side, on the right direction. Getting it? Like as an object is placed over here, I am trying to move it from this direction with some amount of force, while the friction force will be acting on the opposite direction. That is friction, or basically frictional force. Frictional force, friction force in short is basically called as friction. Okay, no? Same thing. So it tries to oppose the movement of the object, right? And it always acts in the direction, in the opposite direction to the direction of motion of the object. Like I'm trying to push it in this direction, or now suppose the object has came into motion, now it is moving, but it does not mean that the friction is no longer acting on it. Even if the object is moving, the frictional force is acting on it, and it's acting on the opposite direction. The object is moving in this direction, the frictional force acts on the opposite direction. I hope that much is clear so far, right? These things also I have just explained. Please, one of you, please read the given paragraph.
Friction slows down moving objects and prevents stationary objects from moving. Friction has a dual role. For moving objects, it acts as a drag force, gradually reducing their speed until they stop. For stationary objects, it acts as a barrier that must be overcome to initiate motion. E. Friction arises due to irregularities between the surfaces. The irregularities on the surfaces in contact tend to interlock, creating resistance when one surface tries to slide over or move over the other. Even seemingly smooth surfaces have microscopic imperfections that contribute to friction.
Hmm. Okay. So friction slows down moving objects and prevents the object that are at rest from moving. Okay. So if there's a stationary object, right? Like a piece of rock is kept over here, a giant piece of rock is placed over here, and sorry, it's placed over the grassland, like suppose like this. And in order to make it move, in order to make this move, I must break the barrier. Like there is some friction between the rock and the ground now. Just as the two surfaces are in contact with each other right now, so there is some friction. Yeah. So there is some friction between this ground and the rock right now. And I need to actually break down this barrier. Like this friction is acting as a barrier to me now. It's a barrier, right? I must break down this barrier in order to make this object move, this rock move, right? And that barrier, like how much it's going to be, it will depend upon various factors. Okay, it's going to depend upon the various factors. Okay, is this statement clear? It acts as a barrier that must be overcome to initiate motion. Like I must break down that barrier in order to bring this object into motion.
Yes, sir.
Okay. Then this thing also we have learned. In this important statement I have written here is that even seemingly smooth surfaces have microscopic imperfections that contributes to friction, right? Like even if the two surfaces looks very smooth, right now, looks very smooth, but still it has microscopic imperfection, right? Microscopic, you mean, no? Like when you will be viewing it under a microscope, then you will find that there are some imperfections in it, right now. So because of that, it will become difficult to move two uh, seemingly smooth surfaces that are in contact with each other. Getting it? No? Suppose for this, like what you can take, what you can do, you can take two surfaces, like you can take two wooden boards, right now, two wooden boards that are seemingly having a smooth surface. And if you were to place one over another and you try to move it, right now, so you will feel slight amount of resistance while moving one over another. Getting it now? Although it is appearing very smooth, but it has small imperfections in it. That's the thing. Now the question is like, what are the factors upon which the friction will be depend upon? Right now, like how much of friction is going to be there between the two surfaces? There must be some factor that will be determining it. So in general, like there are three factors, but I have written few more factors here. In general, it depends upon the surface roughness. What does it depend upon? It depends upon the roughness of the surface. Getting it? Or basically nature of the surface here, right? So if there are two surfaces like this, and there are two surfaces that kind of looks like this. So obviously, in the first case, like we are having rough surfaces, right? Rough objects, or I mean to say objects having rough surface. So there will be more amount of friction here, right? That's the thing. Second factor depends upon the degree of contact between the two surfaces, or simply the surface area, like how much of area is in contact with each other. Getting what I'm trying to say? Like again, say that we have two objects like this, and here we have another objects like this. So clearly, we can see that in the first case, there's less amount of area in contact now, but in the second case, there's more amount of area in contact. Getting it? So in this case, since the surface area in contact is more, there'll be more amount of friction in this. All right.
Yes, sir.
Now the third factor is the force pressing the surfaces together. Force pressing the surfaces together. To understand this, suppose you have taken two rocks. One weighs 5 kilogram, another weighs 10 kilogram, right? 5 kilogram and 10 kilogram. And by the way, you guys know that by the virtue of our weight, we are applying a force on the earth. We are applying a downward force. What is our weight? Weight is basically a kind of force now. Weight and mass is different, you know. Mass is the amount of like amount of content present in our body. Getting what I'm trying to say, or kind of getting it confusing? See, mass and weight are different things. Mass and weight are different things. Don't confuse it with the same thing. Mass is the amount of matter in our body. How much of muscles, how much of bones, how much of different things are present in our body, that is our mass. Getting it what I'm trying to say?
Yes, sir.
Yes, sir.
Right? While the weight is different thing. The weight is the force exerted on that object due to gravity, right? Weight basically is the weight, we define it as the like it's dependent upon the gravity, right? No, it depends upon the gravity. So weight is the force of gravity on an object, while mass will remain same. No matter where, whether you are on equator or whether you go to the pole or whether you go to moon or whether you go to Mars or some other planet, your weight is your mass is going to be same. You're going to have the same amount of muscles and the bones and everything, right? But will your weight be same? No, because gravity of different places are different, right? Do you guys know? Okay, you guys tell me about this thing. You guys have heard about gravity, right? Gravity,
Yes, sir.
right? No, the force by which an object is attracted towards another object. Particularly in the case of Earth, it will be the force by which every object is pulled towards the center of the Earth. Okay. You guys know that our Earth is not perfectly spherical in shape, right?
Yes, sir.
Okay, no, it's oblongoid. Like we say that it's kind of oval, right? No, our Earth is not perfectly spherical in shape. So to the center, the pole is closer to the center, or is it the equator? Tell me. Our Earth kind of looks like this, right? And here is the, hold on, this is the center of the Earth, and this is the pole over here. Okay. And that's the imaginary line. That's basically the equator. So tell me, let's say I have drawn this line and this line. So which is closer to the center of the Earth? Is it the pole or is it the equator?
Equator.
Equator is closer. It's
Sir,
pole. Pole actually. Look at the length of the lines I have drawn here. Look at the length of
Okay.
the two lines here, right? So when you are at the pole, you are actually closer to the center of the Earth, right? And remember this thing always, that when the distance between two objects are less, the amount of gravity is going to be more. Okay, it's going to be more. And here, when you are actually on the pole, right? So you will be experiencing a slightly more amount of gravity. Although it will be negligible, you won't even feel it. But when we will calculate it, we find it out that there's more amount of gravity on the pole in comparison to the Earth. Oh, sorry, equator. That's the thing. Okay. Anyways, gets back to the main concept here. This thing, I suppose you guys have learned something. Like, is it clear? Not getting it,
Yes.
Mustafa? Getting
So
it?
I'm
No?
getting
Oh,
yes.
okay. Now coming back to this concept here. I hope the weight concept of weight and mass is now clear.
Yes,
Mass
sir.
is the amount of things present inside our body, the muscles, the bones, etc. But the weight is basically the force by which we are pulled towards the earth. Okay. Yeah. So I'm saying that these are two objects, right? They are having different weights here. This one is having 5 kilogram of weight. This is having 10 kilogram of weight. Okay. By the way, if we are to particularly talk about the weight now, let me tell you, like, the correct unit of weight should actually be Newton then. Okay, no? Since weight is the force by which an object is pulled towards the earth. So let's say this is having a weight of 5 Newton. This is having a weight of let us say that 500 Newton. Okay. And weight is by the force by which we are attracted towards the earth. Okay. So clearly this object is like the here in this case, as it is placed on the ground, this is also placed on the ground. So clearly this is exerting less amount of pressure, less amount of force now on the ground. It's pressing the ground with less amount of force. But this body being bigger in size, having more amount of weight, so it's pressing the surface of the earth with more amount of force, having a 500 Newton force. Getting the thing or not?
Yes, sir.
Hmm?
yes, sir.
So that is the simple concept here. Okay. Or to make it even more simple, just understand this thing. A heavier object is placed and you have a lighter object. So obviously it will be difficult to push an heavier object because it is pressing the earth with more amount of force. It's pressing the earth with a more amount of force. Okay. Then it's also the type of motion. The type of motion also determines the friction. Okay. Now the question is that, like, how is it going to be? How the type of motion will determine the friction? Hmm? So see, the type of motion between two surfaces, it will determine the friction in the following manner. Like there are generally different types of friction, right? We have static friction, we have sliding friction, rolling friction, etc. Right? In the case of static friction, you will get to know that this will occur. This static friction will come into existence, right? When the two surfaces, like when one object will not be moving over the another object. Like as you can see here, this guy is trying to move this object, but it is not moving, right? So that is a static friction. The object is not in motion at all. But once the barrier has been broken and now that object has came into motion, right? It's sliding over the ground. So there is a sliding friction here. Now, to make it much easier, now we have placed wheels at the base, and now you can simply roll it over the ground, like you can see as this boy is doing over here. Should be learning about this thing also. Okay. So it depends upon the type of motion also, like whether we are sliding motion is there is rolling motion, like how it is being moved. So that also in a way determines it. Okay, na? That's the thing. Now there are some other factors also, like temperature, there's lubrication, material used here, smoothness, like we have already discussed this thing, right? Now question is like how the temperature will determine the friction. How is it going to determine the friction between the two surfaces? You guys keep your cameras on. Priyanka, Abu Bakr. So I was saying that temperature also affects the friction. It also affects the friction. How so? See, whenever we increase the temperature of most of the solids, right? It leads them to expand, it causes them to expand, right? Getting
Yes.
it?
Yes, sir.
And as it will be expanding, so it will lead in increasing the friction. Why? Because the irregularity on the surface will increase, right? The surface will become irregular. So as the temperature is increased, many objects would expand. It will cause their surface to become rougher. At a very microscopic level, we get to see that the surface has become rougher, and then it will lead to increase in the friction. Getting it? What I'm trying to say. Then third is lubrication. Okay, like if I'm moving an object over a rough road, right? It will be difficult in comparison to moving it over. Not this one. Oh, sorry. I basically mean to say that suppose if I am moving some object, okay, and I'm moving it over the marble surface, like I'm moving it over the marble surface. So it will be quite a difficult task. But if someone has spilled oil on the marble surface, then it will become very easier now, because I have used a lubricating substance here, right? It reduces the friction here. So how much of lubrication is there between the surfaces? That in a way also affects the friction. That in a way also affects the friction. So let us conclude the different things we have discussed so far. Okay. So in majorly there are three factors, but I have told you some extra things also in this. Okay. The factors that affects the friction are majorly three. First one, I would say it's the surface roughness. More the roughness, less will be the friction, right? Am I correct? Huh?
Yes.
How am I
Sir,
correct?
more roughness, more friction.
More roughness means more friction, no? Less
So what
roughness
is
means, I said more roughness will be equal to, like, it will lead to less friction. So that statement is false now. More roughness, more friction, right? Okay.
yes.
Second, I was saying that surface area in contact, right? So if the surface area in contact is more, tell me what will happen if the surface area in contact between the two object is more. Friction will be more or will it be less?
So can you repeat?
If the surface area in contact is more, 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 so
Yes, sir.
then the friction will be less or will it be more?
So if the surface area is more, it will be friction will be more.
It will be more, exactly, right? That's the thing. Okay. Then another thing here is the force pressing the surfaces together. Force pressing the surfaces together. By this, what I have told you that if you have a heavier object and a lighter object, so clearly the heavier object would be applying more amount of force on the object on which it has been placed, right? Basically, assume that this is the surface of a table, okay, and here I have placed a rock, right? And this rock weighs, let's say, 5 kilogram, and on the other hand I have placed this rock that weighs 50 kilogram. So which one will be easier to push? The one that is weighing just 5 kilogram, right?
Yes, sir.
Why so? Because this object is pressing
Lighter.
it's lighter, it's pressing the surface with less amount of force, no? It's pressing this surface like it is applying a force on the surface. Getting what I'm trying to say? It's applying a downward force. It's kind of pressing the ground of the or the table on which it is kept. Suppose Abu Bakr and Priyanka, you guys getting it or not?
Yes, sir.
Yes.
While this object in my hand, while this object over here, it's pressing the surface with more amount of force. That's why it will be difficult to push that object. Also, this object which I am holding, this object here, the friction will be less or more. Tell me. This one over here, the friction is going to be more or less?
Less.
Less, exactly, because it is pushing the, like it's pressing the surface with less amount of force because it is lighter. But this, it's pushing the surface with more amount of force. So hence friction will be more. Got the concept, everyone? Sorry. Okay. So third would be
Yes, sir.
force pressing the surface together. Okay, hope that much is clear to everyone. Abu Bakr, I talked to the counselor. I had a word with her. She told me that, like, basically what you had to do, Abu Bakr, you need to basically tap on the option. You will find few more questions mentioned over there. You have to basically scroll down or something. Okay, na? You
Sir,
guys
let me
know.
try.
Mhm.
Sir, I'll check right now.
Okay, check it. Either you tap on it or there might be some option of scrolling down. You will find few more questions mentioned over there. Okay, na?
Yes, sir.
Also, I have a small request. You guys please do one thing. Whenever you upload your assignments, okay, first click pictures in your phone, save it, and then upload it. Like, do not take pictures using the application, using that Learnivio application, because the pictures of your assignment are kind of rotated. And even if you guys are preparing the PDF, make sure that the pages are not like randomly rotated left, right, up, down like that. It's in proper manner. Okay, no, everyone.
Yes.
Yes, sir.
Hmm. Okay, if you have any questions from today's discussion, let me know.
No, sir.
Also, if the question will be asked in
No,
the
sir.
exam about
That is not working.
it's not working,
No, sir.
okay, please contact the counselor. Please contact them and please tell them the issue. Okay, no, please tell them. So I was saying that surface roughness, surface area in contact, and force pressing the surface area. These are the three major factors